Speed up science, learn faster, understand better. Why does water push harder the deeper you go? Let's discover the science of pressure. Have you ever felt pressure in your ears while swimming underwater? Have you wondered why dams are wider and thicker at the bottom? Or how you can drink juice through a straw? All these everyday experiences are connected to pressure in fluids and atmospheric pressure. Before understanding fluid pressure, let us first understand pressure itself. Pressure is the force acting on a unit area of a surface. Its formula is pressure equals force divided by area. The SI unit of pressure is the Pascal, represented by the letters PA. Pressure depends on two factors, force and area. When the same force acts on a smaller area, it produces greater pressure. This is why a sharp knife cuts better than a blunt knife. A sharp knife has a very small contact area, so it produces greater pressure on the object. The same idea explains why high heels sink more deeply into soft ground than flat shoes. High heels apply a person's weight over a much smaller area. Flat shoes spread the same weight across a larger area and therefore produce less pressure. Now, what exactly is a fluid? A fluid is any substance that can flow. Liquids such as water and oil are fluids. Gases such as air are also fluids. Fluids exert pressure on the surfaces that come into contact with them. Unlike a solid object resting on a surface, a fluid does not apply pressure in only one direction. A fluid exerts pressure in all directions. Water inside a bottle pushes downward on the base, sideways on the walls, and even upward on objects placed inside it. Fluid pressure also increases with depth. Imagine a bottle filled with water and three holes made at different heights. Water from the lowest hole travels the farthest. Water from the upper hole travels a much shorter distance. This happens because the lowest hole experiences the greatest water pressure. The deeper we go into a liquid, the greater the amount of liquid above us. The weight of this liquid produces pressure. Therefore, a diver experiences more pressure as the diver moves deeper into the ocean. This increased pressure can create discomfort in the diver's ears. This principle is also used while constructing dams. The pressure of water is lower near the surface and much greater near the bottom. That is why a dam is built thinner at the top and much thicker at the bottom. The stronger lower section helps the dam withstand greater water pressure. Fluid pressure depends mainly on the depth of the fluid, the density of the fluid, and gravitational acceleration. A denser liquid produces more pressure than a less dense liquid at the same depth. However, the pressure at a particular depth does not depend on the shape of the container. Now let us look above the water and examine the air around us. Earth is surrounded by a huge layer of gases called the atmosphere. Air has mass, and because Earth attracts it through gravity, air also has weight. The pressure produced by the weight of air is called atmospheric pressure. At sea level, standard atmospheric pressure is approximately 101,325 pascals. This means that the air around us is constantly applying a large amount of pressure. But we are not crushed because the fluids and gases inside our bodies exert an outward pressure that balances the external atmospheric pressure. Atmospheric pressure also explains how a drinking straw works. When you suck air from a straw, the pressure inside the straw decreases. The atmospheric pressure acting on the surface of the drink is now greater. It pushes the liquid upward through the straw and into your mouth. The same pressure difference is used in syringes, droppers, suction cups, and vacuum cleaners. When the pressure inside these devices is reduced, the greater atmospheric pressure outside pushes air or liquid into the lower pressure region. Atmospheric pressure decreases as altitude increases. At high altitudes, there is less air above us, so atmospheric pressure is lower. This is why some people find it difficult to breathe on high mountains. Airplane cabins are also pressurized to maintain a comfortable and safe air pressure for passengers. Let us quickly revise. Pressure is force acting per unit area. Fluids exert pressure in all directions. Liquid pressure increases with depth and density. Atmospheric pressure is produced by the weight of the air surrounding Earth. Pressure differences make straws, syringes, suction cups, and many other devices work. Here is a quick question. Which part of a water-filled tank experiences the greatest pressure? The top, the middle, or the bottom? The correct answer is the bottom, because liquid pressure increases with depth. Thanks for watching and keep learning with Speed Up Science. Like this video, subscribe to Speed Up Science, and visit speedupscience.com for more exciting lessons.